Today we're going to look at two example problems involving calculation of density. We've already figured out what that density is, the mass in every 1 unit of volume. And now we're actually going to perform some calculations with it. So, aluminum contains 2.7 grams for every 1 milliliter. That just is the density of aluminum. Remember, the density, when you see it standardly stated, is going to be the mass for 1 milliliter. If the volume of an aluminum can is 5.3 milliliters, so we have 5.3 times as much aluminum, what's the mass of the can? There's just like a proportion in math class. We know that there are 2.70 grams for every 1 milliliter. And we want to know, well, when we put an X, that's what I want to know, how many grams are there if I, instead of having 1 milliliter, I have 5.3 milliliters. So when you get a proportion in math class, what do you do to solve it? Cross multiply. So that's exactly what I'm going to do. I'm going to take 2.70 and I'm going to multiply by 5.3, and then I cross multiply the other way. It's x times 1, which is just x. I'm leaving off the grams and the milliliters because some people get confused. Those are units. They're not variables, two separate things. And if I leave those units in during the algebra, sometimes people will get confused and think that they're variables. They're not. They're just labels telling how stuff was measured. So I'm going to calculate here. 2.7 times 5.3, I got 14.31 equals x. Now, I'm not done. There's a couple things every answer needs to have. It needs to have the correct number of significant figures, and it needs to have a label. Let's look at sig figs first. Multiplication division rules say that your answer should have as many sig figs as the worst number in your problem. Well, we've got 2.70 grams. That has 3 significant figures. That 0 is significant because there's a decimal. When there's a decimal, trailing zeros matter. 5.3 is easy, there's no zeros, so it's just 2 sig figs. Of those two, 2 is the smaller number, so my answer should have 2 significant figures. So I'm going to round my answer to 2 significant figures. I want to round to the ones place. There's a 3 behind it, so 3 says that 4 stays the same. So my answer is going to be, rounded to 2 significant figures, 14. It needs a label. Well, we were trying to find grams, so it's 14 grams. That is the mass of the can in 5.3 milliliters. Let's look at one more problem. I'm going to solve it the same way. We're given the density of copper. Copper contains 8.96 grams for every 1 milliliter. Again, if it's in terms of 1 milliliter, it's the standard density. If a robber stole 5,600 grams of copper gutter off my house, which sadly did happen once, what volume of copper did they steal? So again, we're going to just set up a proportion. There are 8.96 grams of copper for every 1 milliliter of copper. But we didn't just have 8.96 grams. There were 5,000, a whole lot more, 5,600 grams of copper. And I want to know how many, so x, milliliters did they steal. Again, it's a proportion, so let's cross multiply. 8.96 x equals 5,600 times 1, and I need to divide both sides by 8.96 to get the x by itself. On this side it cancels out, and I'm left with x equals 5,600 divided by 8.96, and that is 625. But again, my answer needs the correct number of sig figs and a label. So I look back to my problem. We've got 3 significant figures here, and we've got 4 here. Why is that one 4? Well, you notice I was very careful to put a little dot there. And that dot, that decimal point, is telling me that those 2 zeros are significant. When there's a decimal present, trailing zeros are significant. So of those two numbers, 3 is smaller. My answer should have 3 significant figures. Hey, wait, it already does. So I just need a label. We were trying to find milliliters. So my answer is 625 milliliters is the volume, the space taken up by 5,600 grams of copper. Before I leave you, 2 other things I want to point out. Why am I ignoring this 1? Well, the 1 is just the denominator. It's the number that was actually measured is actually the density. So when we're saying for every 1 milliliter, that 1 is really not going to play into our significant figures ever. It's just a placeholder in the denominator, you could say. Second thing I want to point out is that when I say 8.96 grams for every 1 milliliter, you will sometimes see problems that don't write out that whole phrase. In other words, the density will just be written as 8.96 grams divided by milliliters. That's the same thing. You can use that density in the problem the same way I did in these examples. So it's time for you to try some problems on your own.